Okay, case one. So if you have one side and two angles. So if you have a triangle, you're solving a triangle problem. You have one side and two angles. One side and two angles are known. That's how I will phrase it. We call those ASA and SAA. Case two. When you have two sides and an angle, opposite to one of these sides, that would be case two. So basically, as long as an angle is opposite to one of the given sides, a given angle is opposite to one of the given sides, then you can use law of sines. So case one and case two are perfect for law of sines. Case three, case four are not. These are for law of cosines. This is when you have two sides and the angle given is not opposite to those sides. Because if it's not opposite, then you cannot use sine, which is the whole point, right? For law of sines. Another version of that issue is you have nothing but sides. So you have three sides and no angles. Then that's case four. Okay. All right, so this homework will focus on case one and case two. Then go ahead and give you the law of sines definition here. So the law of sines. So for a triangle with sides A, B, C, lowercase, and opposite angles A, B, C, respectively, the following is true. Or holds. Number one. So this is the law of sines. Sine A over little a is equal to sine B over little b, which is also equal to sine C over little c. So basically, they are all equal to each other. Number two is basically the same thing, but if you flip them over, you can do this. These are still equal. what I recommend is, here's a note. Use number 1 to find angles. Let me rephrase that, to solve for angles. So if you know you need to find an angle, use the first one. Use number 2 when solving for a side. Here's my generic attempt at a triangle. So this is angle C. So this would be side C. This is angle B. So this would be side B. This is angle A. Side A. So as long as you do the angles that match opposite, the lowercase a and capital A for B and C, then you'll use these formulas. All right, so that's the background that we need in order to start solving them.
I have a question about the A and B angles. So for like the big A, C, and B, do they have to be in those positions, or could like B be at the top and C be at the other angle where B is at?
Yeah, the locations don't matter, just make sure the corresponding opposite sides match.
Perfect. Okay, cool.
So if I put A, capital A up here, then little a better be here.
Got it.
All right, so let's start some examples. You guys cool? Return the page.
Yes.
Good. All right, so example 1. Solve the triangle.
Wait, did you say that they all most of or all the angles add up to 180? I don't know if I heard you say that.
They will, yes. All triangles will add up to 180, right?
Yeah. Okay.
If they don't, then it's not, you do not have a triangle. Okay. So in this example, let me see if it's the first one or which one am I doing? I think I'm just doing a different one. That's fine. Let's start with this. So they're giving us capital A, capital B is not given, capital C is given, little a is not given, little b is not given, little c is given. I think in this one we'll say that we have a random triangle. They're not isosceles, it's just I just can't draw. So capital A I put there. I need to find little a. If I put B here, then I gotta find little b. C, 100 degrees. So little c is right there. Okay. So right away, you should be able to find capital B, right? The sum of all triangles will always be 180.
Would it be 20 degrees?
Yeah, it has to be, right? So if you're not sure, you just basically subtract all the other angles from B, from 180, and you will get B. Then you guys said 20, right? Okay, I'm gonna box the ones that we find. That way we know what was done. All right. So I'm gonna find side A first. So this is step 1, step 2. Okay. So I'm going to choose to set little a over sine A. You get to choose whatever you want. Set it equal to the one that has both parts. C over C would work, right? Because it has both. I don't have little a or little b, so I can't use those. So, and I'm solving for a, so I'm going to set it equal to little c over sine C. Do you see the logic as why I chose this one?
No.
Okay, so you can choose anything you want, right? Because these are all equal to each other. I'm choosing to use number 2 because this is easier to find the sides, and I'm finding side A. Now, if I choose to set up the equation, you want to have only one unknown, not two unknowns. So I'm solving for A. So I need to make sure, do I have capital A? Yes, right? I have
Right.
little c and sine C. So I have the C's, so that means I would only be solving for one variable. So I can actually finish this. Now, if you would have chosen this one, right, B over sine B,
Mhm.
you would have little b missing and little a missing, and you can't solve it.
Oh, okay.
So choose the one that has both pairs to set it equal to.
Oh, okay. I see. Thank you.
Once you set it up, just solve for a and plug stuff in, you'll be good. Oops, smeared it.
Right, because they all equal each other.
Yeah, so you can choose whatever you want. Just choose the one that helps. But if you pick the wrong one, you'll know right away you can't do anything.
Okay.
All right, so I'm going to multiply both sides by sine A here. These are gone. So that means that A is equal to C sine A over sine C. I'm sorry, my C's look the same. Just, I don't know, make sure you know they're different. So little c sine of capital A over sine capital C. And punch this into your calculator. I believe it's 3.5. Is that what you guys got? Make sure you're in degrees.
Oh, can you move the calculator a little bit to the right?
Hmm?
Yeah, that's what I got. 3.51754.
All right, so around to, I don't know, one decimal place, I guess. they'll tell us in the homework what they want. Okay, so now I have little a. So step 3. Find little b. So I'm going to choose to set b over sine b equal to the same one, the c over sine c. Because that was given to us and I trust that more than my rounding. Multiply both sides by sine b, you're going to end up with this. Skip a minor step there. Plug in everything. So you'll have 4 sine 20 over sine 100.
I got 1.389.
Yeah, that sounds right to me. So we'll put 1.4, I guess. Whatever. Anyway, any questions on the process? Does it make sense what we're doing?
Yes, it makes sense.
Yeah, it's really simple. This one is, I don't know about the homework.
Yeah, homework will be similar. The only time it gets hard is when you have multiple triangles within one problem. Those are the hard ones. But for the most part, this is the process.
Okay.
Also, this chapter is a lot easier than the last chapter.
Oh, that's good.
Okay. Any other questions on number 1? All
No.
right, so if you're given two angles, then you can safely assume that there's no what's it called? There's only one triangle because it's already defined. You know what I mean? So let me see here. Yeah, if you're given 2 angles, then the other one can only be one specific angle. But if you're given only one angle and you start solving for the other ones, then each time you solve for one, you could have 2 different solutions per angle. Because you remember when we were solving for theta on the last chapter, you'd have theta 1 and theta 2, right? You would subtract from 180.
Right.
So you have to check, do they both work, both angles? And if they do, then you end up creating a second triangle that's, has different sides and angles. But if if only one works, then you only have one solution. If you end up getting a weird error when you're trying to solve, then there is no triangle. It just never closes. You just get sides and angles that tries to form a triangle, and it turns out there never was one. So let's start. Let me give you the process as to how to check what scenario you're in. Because right now we just solved it without knowing or caring if there was one or more. We also didn't have to solve for an angle, so. Two sides and an angle are given. Determine if you have 1, 2, or no triangle. So here I'm just gonna say, you know what? Solve for the missing pieces. I am giving you one angle. So this kind of gives you, this gives the possibility of multiple. All right. So I'm gonna use formula number 1 to solve for, well, first of all, what would you solve for first? Right? Because I'm not gonna tell you all the time, or I won't be there when you're doing your homework.
B?
But we have both B's, so we're gonna use that. We're gonna set our question equal to this one for sure, right? But what do we want to solve first?
Maybe
Capital
C.
A, little a, or capital C?
Capital C.
Yeah, we want to do capital C first because it has a pair, right? This has
Right.
2 unknowns and we can't do it. Do y'all see the logic?
Yeah, it's much easier because you already have one value. You're just have to find the other.
Yeah. Okay, so step 1. Find angle C. So I'm going to set sine capital C over little c equal to sine B over little b. Multiply both sides by C. That gets me to here. Let's do sine inverse of both sides. So now we know that C is equal to sine inverse of this weird garbage. Five. Okay. Let me slow down for a second. So we did the algebra to solve for angle C, right? Just like we have in the past. So I had to get rid of that little c, do sine inverse of both sides to cancel the sine. These cancel, giving me C by itself, capital C. I have all these values, so I can just plug it in, which I did here. So now what is this going to be? Sine inverse of,
Is that
let me use- go
140?
ahead.
Oh, it's
Ye-
sine inverse. Yeah, let me do that. I totally missed, but sine
Oh, that's-
inverse. So it's 5 sine inverse?
Yeah, the sine inverse of 5 sine 140.
Hmm.
So all that is inside. So angle C is 27 point whatever. We'll round to 1 decimal place, I guess.
Yeah, 27 point. Okay.
Yeah, so we're gonna call this C1. So this is when we gotta check. Okay, well, based on the last chapter, we know that the other angle would be 180 minus C1, which is, so I'm just do 180 minus that answer.
152.668.
Yeah. So we'll say 152.7. We've got two possibilities. So now the question becomes, do they both work or do only one of them work? Since I didn't get any error while solving, there probably is one triangle. There could be two. So that's why I got to do this. So that's why when you're only given one angle, the question is a little harder. But the process is still the same. There's just some extra stuff. Okay. You guys cool up to this point so far?
Yes.
Okay. So to determine if you have one or two triangles, check if C1, or we can just say B plus C1, capital C, is less than 180, and B plus C2 is less than 180. If they go over 180, then they do not, it doesn't form a triangle, so you would rule out that angle. If only one of them does it, then that's your solution. Don't worry about two. Just go back to doing it the way you did the first question, example 1. So let's check. So B plus C1 less than 180. Is this true? 140 plus 27.3. That is indeed less than 180, right?
Yes.
So that is 167.3. So cool. Now check the other one. Is B plus C2 less than 180?
No.
No. That's way too big, right? This does not form a triangle. So since only B plus C1 is less than 180, then we only have one triangle to solve. If they were both less than 180, then we'd have to solve two separate ones. Does that idea make sense?
Yes.
Okay, so we ruled it out. Now we'll just focus on finding A, B, C, whatever. We got C1. It turns out there's only one C, so who cares about C1, C2? Just C. Now that we have capital C, we can easily find capital A, correct? I don't know, I'm doing the next page. You guys cool on this page?
Yes.
Yes.
Second. All right. Step 3, I think. I guess I should say the testing part is step 2. Okay, once we determine that, we can go back to solving the triangle. Step 3, solve what is it? Capital A, right?
Yes.
So A will equal 180 minus 140 minus it was 27.3, right? I think. Yeah. So what will that be? $12.7 degrees. Okay. 12.7 degrees. All right, we got A, B, C. Now we just need little a, and we're done. All right. So I'm choosing this one because it had both parts when I started. Multiply both sides by sine A, and you end up here. So this will equal 7 sine of 12.7 over sine of 140. This will be little a. Seven
2.39.
What is it?
2.39.
Sounds right to me. Let's see, double check. 140. Yeah. Little a is 2.39. So we solve for this one, this one, this one. Okay, we just had an additional step to check. So we found out there wasn't another one. Cool. Any questions on example 2?
No.
All right. Let's do one that has 2 triangles. That's the hardest type. So far we did 2 that only had 1 triangle. One where we had to verify, and the other one where it was guaranteed to be 1. So here we go. So I'm gonna tell you after that there is one, but we are still gonna check and do the procedure just so we have practice. Okay. Was this from the homework or no? I don't think so. One moment, let me forgot to, let me find an example, one sec. Okay. BA, row A. This is given. Little b is given. Little a is also given. Oh, I see. Okay. Yeah, we're good. This will work. No, just my brain froze and so. Okay, so number 3. We're gonna find capital B first. And use this as our guide to solve for capital B. All right, so here we go. Assign capital B. Oh, let me write this step first. Assign capital B over little b will equal sine capital A over little a, because those two are a complete set. Multiply both sides by capital or lowercase b to get to here. Sine inverse of both sides will get you to here. All right, so plug it in and we should be good. We got BA sine A. $11.4 sine of 54 over 9.7. What is that going to be?
I got 71.95.
Okay, let's round to 72. Okay. So B1 is 72. B2 is 180 minus 72. We have two possible angles. So we need to check. So determine. Right, check if B1 plus the angle that was given, let's use, I don't know, A. And B2 plus capital A. If in this case, they're going to both turn out to be less than 180, so we will have to solve 2. Okay. So we got 72 plus 54. That'll be,
126.
yeah. This guy will be B2. Hmm. 162, right?
160.
So since both B1 plus A and B2 plus A are less than 180, then we have two triangles. Life sucks. Okay. So we'll do that on the next page, solve both. Probably should have put them up there. Oh well. Okay, so far you guys still with me?
Yes.
Okay. So over here, I'm going to put triangle 2 and I'll come back to that page. Okay, so capital A will not change. Lowercase a will not change. B2 we found to be 108. C2 we can find no problem. Capital C. B2 will be the same. I believe it's 11.4, right?
Right.
Okay. So we can find C1 because that will be equal to 180 minus A1, which are the same. A2 and A don't change. A minus B1. So 180 minus 54 minus, what is B1?
Was it 72?
Yeah, so I'm going to call this B1 over here. And C1, C1. Okay. And that will be, what is C1?
54.
Yeah. Yes. So 54 degrees. We'll put that over there in a second. Okay. Now we can solve for C2, C1 as well. But I guess we can go ahead and find C2 real quick. It'll be 180 minus A minus B2. So that'll be 180 minus 108 minus, oops. 54 minus 108.
It's 18.
Yeah, 18. Okay, so we got the capital angles. This one is 54. Okay, now we'll find the little c's. Okay. Alrighty. C1, we'll set this one. Make sure you use the same matching variables. I'm gonna use the A's because they don't really change, so this is better. So C1 will equal A sine C1 over sine A. Plug everything in and you should have 9.7 sine of 54. No.
Yeah, 54 for the C1.
Okay. Yeah. Just tripped me out because it was the same as A in, yeah.
Oh,
Anyway, yeah, you're right. Turns out to be 9.7.
right.
C2 will be almost exactly the same. So I'm just gonna go ahead and do it. A sine C2 over sine A. So that'll be 9.7 sine of 18 over sine 54.
Three 3.67.
3.7.
Yeah,
3.7. Okay, so we found this guy, this guy. This was found earlier. The rest was given. All right. Over here, C1 was 9.7. Any questions? You see how when you have two, it gets kind of annoying. Do you have any questions on the true triangle problem? But it's the same thing over and over again. You just got to figure out, what am I solving for? How do I check? And just cycle through each missing piece.
yeah, it's a lot easier than when our first ones where we're like verifying the trigonomic functions.
Yeah,
These
this
are
is
pretty
more,
straightforward.
yeah. Yeah, this is more like, we're solving things here. Or more application instead of theoretical. Okay. Um, 3. All right. So let's do one more example. This time there will be no triangle. want you to see that case too. I think there's a problem 9 from the homework, but I forget. Let me check. Yes, this, well, kind of. It's the numbers changed. Who cares? Okay, so you're given these 3 pieces. Try to solve for capital B because that's the only one you can really solve for since it has a matching pair. You cannot do anything with these because they're both gone. So capital B will be first. So sine B over little b will set that equal to the one that has the complete pair. Multiply both sides by little b, and then do your inverse. So capital B is equal to sine inverse of B sine, let's write it again one more time. $250 sine 100 over 175. So as soon as you try to punch that in, you should see an error.
Yeah, I got an error domain.
Yeah, so that tells you that there is no solution for capital B. And you should remember from chapter 1 that sine inverse, or maybe, yeah, I think it's, or maybe chapter test 1 or test 2, but the inverse domain, the domain can, inverse sine, the domain of inverse sine is between 1 and -1. So this is bigger than 1. So it can't plug that in. So if I can't use this, then there is no B. So this is an error. Domain error. So basically what we're trying to solve is some weird triangle like this. It just never closes. And that happens. Like, given some information, it just wasn't going to happen. Those are the 3 cases.
And
One
that'll be
triangle.
on our upcoming test, right? We'll have some solutions where it'll intentionally be an error.
Yeah, it'll come up in the homework, and you'll see, maybe probably in the exam too. You'll try to solve it, and there might be 1 triangle, 2 triangle, or no triangles. And you just state, explain if there's none, just tell me why, or if there's 2, solve them, and if there's just 1, solve that. You should be good. Okay, so the three cases you'll run into your homework. The very end, there's a form, you find the area of the triangle, just use a formula. I don't know if I have it with me, let me see. Dang it. 8.1. Do I have all the sides on these? No. Give me a moment. Let me see if I can get the book. Oh, that's not the book. We are in chapter 8, right? Nope. Chapter is this? Oh, here we go. Okay. So the formulas, let me find them. It's right here. Yeah. So basically they take the idea 1/2 base times height and they change it into a formula. So there's 3 of them. Depending on what you have, you can use 1/2 BC times sine A or 1/2 AC sine B. Oh, here they go. Here they are. The 3 different ones. I'll write that on the notes real quick so you can have it. I usually prefer Heron's formula or Hero's formula. But we'll talk about that next time. But here are these just in case you want to use this for now. One half AC sine B, 1/2 AB sine C, 1/2 BC sine A. Okay. So use these guys on the last couple of questions. It's just formulaic. See how here we only have capital A, capital B. So you can easily find angle C, right? So once you find it, plug in or find the pieces you need and then plug it in. Does that make sense? A, B, C. Yeah, so this guy right here, the first number 12, A is 122, and you got B and C. So you would use this one. Just plug it in, and you'll get your area. And then here we have A, B, C again, so just plug that in as well. Anyway, you guys have any questions?
Nope.
All right, we'll stop here, guys. If you have any issues or concerns, now's the time to let me know. If not, I'll see you tomorrow. Let me take roll first, though, before I forget. After roll, if you want to head out, you can.
Oh, do you want to stop recording?